Hello everyone, I am Bradley Sward and this is the Day 18 solution to 2024's Advent of Code. Both parts, the problem is RAM run. I'm solving it as always in Python. So just to say, Day 17, an amazing puzzle from yesterday. Apparently I solved it slightly differently than most other people did, but whatever, it's all good. We all got to the same spot. But I started running this and I just happened to have it on when I woke up this morning. I'm like, oh, let's just keep it going. Apparently I need to get a little bit further. This needs to be 215 or something like that to start. So I'm about 80%, 90%, somewhere around there, 80, 90% there. So anyway, coming back, the RAM run. So basically, we have another grid we're working through. We're working through pathfinding, and so the goal is, well, what is the fastest path through a specific field? Well, the field starts out completely empty, and the holes fill in as time go on. Like basically, we're corrupting some RAM grid, but we still need to walk from point A to point B. And so for this one, we're just saying let's add 1,000 points of contention. Let's corrupt 1,024 different elements, and then from there you go, well, how fast can I get from the one upper left hand corner to the lower right hand corner? And my answer ended up being 300 something, 356. So what was cool for part two was basically, I don't know why this was such a simpler problem than some of these other nights, but that's okay. It was fun. But just to say, as I'm adding more and more bytes to this, at what point is it that I can't get from my goal? I can't get from the starting position to the goal. And in my case, when I add this piece here, 2233 adds as I'm adding over and over and over and over and over again. That's what it is. So anyway, coming back. So here's my code. Oh, back to that here. Here's day 18, part 1. So basically, it's basically just a simpler version of what we've done even in day 17 and day 16 and day 50. I can't remember exactly which days are which anymore. But I wanted to make sure that I added a grid around everything because I didn't want to add more code to figure out, are you off the grid or are you off the the array or whatever. So basically, I just added an array of just nonsense, just characters to this thing, and I can show you here in a second here. And mine's hard coded. I just 71 by 71, so there needs to be 73 squares with my data set. So you can see here that basically I have a boundary of these octothorpes. Okay, so then I add 1,024 points to the thing. And then I just use the same algorithm I've used before, where I just check up, down, left, and right. Can I go there? And if I can go there, have I gone there better than what I've gone now? And just kind of keep, that's what this part is saying here. And then throwing that thing onto the closed list so that we generate all the different positions, but we generate all the best paths for the thing. So for part 1, when you run things with that understanding, and this is everything right here, right? This is pretty much all the major code for this. There's not a lot to it this time around. We'll get the best position. I think it's 356, and there it is almost instantaneously. Surprisingly, almost instantaneously for how much it needs to process. There it goes. So that's how you would generate part 1. So for part 2, all we're really doing for part 2 is, and again, I was just in the thought of, let's just get a solution. I don't have to be cool. I would use a binary search for this if I was going to update this and make this a little bit more timey than what it is, because right now I just linearly went through and just found the smallest one. But basically, if I know 1,024 doesn't work for me and I have however many data points, I would pick a point halfway between that and the end and go, does that one work for me? And if that's the answer is yes or no, well, I work my way one way or the other until the one I'm on is a yes and the one before me is a no, and then I have my answer. But that's all there is to it here for day 2. Is just to say here, while I haven't found what I'm looking for, keep adding. And where is it down here? Instead of adding wait, where is it now? This here, instead of adding specifically 1,024, I add whatever number, and I just started at 2920 because I know what the answer is. But I just ran it through previously, and it just comes up. It's trying everything, and then when it gets here, whichever byte number it is, it ends up giving me the 2233. All right, so that's my solution. Easy stuff this time around comparatively. Thanks for watching. If you have any better way to do it, love to hear it. Thanks, everybody. We'll see you next time.